Good morning, everybody. Today we're going to talk about Intro to Rocks and Sedimentary Rocks specifically. So Intro to Rocks is more of the general. We're going to discuss the three different types, and then Sedimentary Rocks is when we get into the specifics. If we take a look, all rocks either are going to be mono or polymineralic. Monomineralic meaning they have one mineral, polymineralic meaning they have many. For instance, monomineralic rocks could be like rock salt, where a polymineralic, if you look here, is going to be granite. If you notice, there's all these different colors here that I'm kind of trying to highlight. And wherever they are, all of these different colors are each different minerals, whereas here we've got the one color, the one mineral. And because of this, most rocks tend to be polymineralic. If they only have one mineral, generally just call them by their mineral name. Now, what form these types of rocks? If you take a look, igneous rocks, for instance, are all formed by magma or lava, which is going to be cooling. Sedimentary rocks are formed by cementation after deposition. I know that handwriting is pretty horrible, but it will get better over time. And then metamorphic rocks are formed from heat and pressure. Okay. So to go down specifically, igneous rocks are formed from magma or lava solidifying. When they solidify, that's when the rock forms. Sedimentary rocks are formed from deposition and then sedimentation of sediments and using natural glues to glue them together. And metamorphic rocks are formed from heat and pressure specifically. So any rock can be a metamorphic rock, even a metamorphic rock. It just depends on how much heat and pressure is being applied. So if you use page 6 of the reference table here, you notice in the rock cycle, nothing has one path. It can always become something else. Sediments, for instance, can loop back around and due to weathering and erosion, become sediments again. Just like I said before, metamorphic rocks can loop back around and become metamorphic rocks. Because it's a cycle, we're always creating new rock and changing the ones that are already existing. So sedimentary rocks, here are three classic examples. For instance, here we got one that is clastic. Here we have one that has fossils present in it, and here's one that we've got live strata, which makes it really easy to identify these. And in New York State, we have a lot of sedimentary rocks. So the first concept is most sedimentary rocks are made of clasts or sediment, which are pieces of weathered rocks that are going to be cemented together. We specifically use the word sediment just to get that in your brain, that sedimentary rocks are created by sediment. Now if you take for the second concept, the two processes that are responsible for the formation of sedimentary rocks are compaction, right here, when we press them together, and cementation, using natural glues like silica. And here's another two very specific examples of the definitions. Okay, third concept, most sedimentary rocks form in water or near water, and that's how we know that New York State was covered with water at one point in time, because there are so many sedimentary rocks. If you notice here, you can see these layers that I'm drawing. These are all the strata that are formed due to the different layers piling up on top of each other. The fourth concept, here are some of the common features that you'll see in a sedimentary rock. One that I just showed you, that I'll show you again in these canyons here, these sandstone canyons, are that these have strata or layers, very specific layers in line. They have fossils. Because they form in water, you've got a lot of mud and sediment going overhead of these animals, burying them and then putting them into different positions. Right here, if you look, this is called life position. Okay, life position means that they were living, then all of a sudden a whole bunch of mud or something dumped down onto them. Okay, some other ones are that they have clasts. If you look here, this is a good example of pudding stone. It's got some mud. It's got all these rounded rocks. Now, because they're rounded, it's pretty easy to tell where they come from, which would be water. Water around sediment, where glaciers and just mass dropping does not. Okay, and here's the chart. So let's go through the chart real quick and make it easy for you. There are three specific textures. You've got clastic, which are ones made of sediment, crystalline, which are ones that are going to form in water, either due to precipitates or evaporates. We got bioclastic, which would come from once living material. So all the clasts here, if you notice, all have different size sediment. You can also use another chart on page 6 to identify where you're going to find them in a stream. Then if you go over here, it tells you what the particles actually look like. Okay, and then finally over here, this is how you determine the name. And then when we get to geologic history, you'll notice that there's map symbols. They're very specific because we don't write the name of the rock down. We just write the symbol that represents them. Here in crystalline, we've got 3 common ones here in New York State. One we use on the road specifically, which would be this guy right here, the rock salt. Okay, and they all mostly come from one specific mineral. So we've got halite doing rock salt, gypsum for rock gypsum, dolomite making dolostone. So they're pretty easy to remember the names. And then finally we've got bioclastic, which we have limestone and coal. Okay, now coal specifically comes from carbon, and limestone comes from calcite. Now there are 2 different types of limestone. You've already seen one of them, and that's called fossiliferous limestone. Fossiliferous limestone is a limestone that has fossils present in it, whereas coquina or shell limestone is specifically made up of shells that have been cemented together. Okay, so hope that helped. Have a good day.